Hello everyone. Last time we talked about average rates of change. Today we're going to talk about the second type of rate of change, which is instantaneous rate of change. This is really the beginnings of calculus. We do this, it's called a derivative in calculus. It's a process that we learn all the shortcuts for. We spend many months learning the shortcuts. Today I'm going to show you the hard way. And yes, you do need to know how to do this. We've been finding the average rate of change between 2 points or over an interval. To find the average rate, we just find the slope between those 2 points. The average rate of change is also the slope of the secant line. Watch the previous video if you're unsure about that. What if we want to find the rate of change not between 2 points? So if you have a curve like this, I don't want to find the slope between these 2 points. But what if I want to find the slope at that 1 point? Well, that's called the instantaneous rate of change. So how do I find it? If you remember from the very end of Algebra 2, you should have learned something called the difference quotient. This is the formula for it. It's the f of x plus h, so I'm going to replace all of my x's with x plus h, minus my original function, all divided by h, when h equals 0, which is why the function is going to, or why the formula is so difficult. If you plug in 0, you just have f of x minus f of x over h. That's 0 over 0. You can't divide by 0, which means we need to manipulate the problem to try to find some way to get rid of the 0 on bottom. Okay? When you use the difference quotient and plug in h equals 0, you'll be left with an expression, like 2x plus 3 or something like that. This is incredibly useful. We will spend months in calculus talking about just this expression. For now, here's what you need to know. This expression is the instantaneous rate of change of the function at any point x. Once you find the expression from the difference quotient, and you want to find the slope at a specific point, or the instantaneous rate of change at that point, plug in whatever that x equals. Let's try a problem. Find the instantaneous rate of change of the given function at the given x value. So here's my function, here's my value. I'm going to do the difference quotient, which says replace the x with x plus h, subtract the original problem, don't forget your parentheses, divided by h. I can't plug in 0 yet, because if I plug in 0, I get 0 on the bottom. Multiply out the top. Remember, this is not x squared plus h squared, it's x squared plus 2xh plus h squared. Distribute that in, you get 2x squared plus 4xh plus 2h squared plus 5. Distribute the negative to both of these things, minus 2x and minus 5 over h. Look for things that will cancel. The 2x squareds cancel. This should have been 2x squared, I'm sorry. Because that should have been 2x squared. And the 5s will cancel. Now every single term that I have left has an h in it, so I'm going to cancel this h with one of each of these h's. So now what am I left with? Nothing left on bottom. I have 4x plus 2h. Now I can plug in h equals 0. If you plug in h equals 0, the 2h is going to go away, and you just get 4x. This is what you get from the difference quotient. But it didn't answer the question. The question was, find the rate of change at x equals 3. So at x equals 3, all I have to do is plug in 3. 4 times 3, the instantaneous rate of change is 12. So the only hard part of this problem is doing the difference quotient. The difference quotient can be pretty tricky. For every polynomial, the process will be the same that we've just done. Okay, distribute out, combine like terms, cancel anything. What about for problems like this, that have a fraction in it? Well, we follow the same rules. 2 over x plus h minus 3 minus 2 over x minus 3 all over h. Find a common denominator on top. The common denominator is going to be x plus h minus 3 and x minus 3. The first 2 was already over the x plus h minus 3, so it just needs the x minus 3. The second 2 was already over the x minus 3, it needs the x plus h minus 3. And instead of dividing by h, I'm going to rewrite that as times 1 over h. It makes the problem a little bit easier to work with. Do some cleanup. You get a 2x minus 6 minus a 2x minus a 2h plus 6 on top. Look for things that cancel. This 2x will cancel with that negative 2x. This negative 6 will cancel with this positive 6. So I'm left with a negative 2h on top. This part of the h will cancel with this h. So this is gone, and this is gone. The only thing that's left on top is the negative 2 that was with the h that you canceled. So I have a negative 2 on top. I have an x plus h minus 3. And I have an x minus 3. The only variable, or the only thing I can do left is plug in the h equals 0. And if you do that, you get negative 2 over. This is gone, so I've got x minus 3 times x minus 3, or x minus 3 squared. This is what I get from using the difference quotient. Now, what point do I need to plug in? Well, I need to plug in the point 2. So at x equals 2. What is my instantaneous rate of change, or my instantaneous slope? Well, that would be negative 2 over 2 minus 3 squared. Negative 2 is negative 2. 2 minus 3 is negative 1. Squared makes it positive 1. Negative 2 over positive 1 is negative 2. So here's an example of a problem with fractions in it. Every problem with fractions is going to look very similar. Find a common denominator and cancel out. Last example I'm going to give you like this. What if it is a square root? Well, same setup. Place the x with the x plus h. Subtract the original problem. Divide it all by h. The only way to cancel out square roots is to multiply by the conjugate. The conjugate is the exact same thing, but with the opposite sign. And since the formula has a minus, the conjugate will always have the plus. If I do it on the top, I have to do the same thing on the bottom. Now, I have a lot to multiply. But, because it's the conjugate, when I go to FOIL, the outside and the inside will cancel. So let's just do this, the first two. 5 times 5 is 25. The square roots are going to cancel out and just leave me x plus h minus 2. The outside is going to give you a positive 25 times those square roots. The inside is going to give you a negative 25 times those two square roots. They're going to cancel. Multiply the last two. Positive 5 times a negative 5 is a negative 25. And the square roots will cancel out and give you x minus 2. All over top of h times the other bottom. If I clean up the top, that's a 25x plus a 25h minus a 50 minus a 25x plus a 50. Let's see what cancels out. The 25x's do and the 50's do. So I have a 25h over h times the square root of, 5 times the square root of x plus h minus 2 plus 5 square root of x minus 2. The h's cancel now. And I can plug in 0 for this h. So on bottom, on top I still have a 25. On bottom, this just becomes square root of x minus 2, and this is square root of x minus 2. So 5 square root plus 5 square root is 10 square root of x minus 2. If you want to simplify your fraction down, 5 will divide both of those numbers, so 5 over 2 square root of x minus 2. That's a lot of work, but we're still not done. That is the instantaneous rate of change everywhere. I didn't want it everywhere, I wanted it at the point 11. So I'm going to plug in 11 for x. That will give me 5 on top over 2 times 11 minus 2 is 9, and the square root of 9 is 3, which will give me 5/6. So those are the 3 types of examples you're going to see. Polynomials, fractions, and then this is radicals, where we use the conjugate. One more question I could ask, and it's going to talk about tangent lines. A secant line is a line between 2 points. A tangent line is just a line that touches the curve at 1 point. Its slope, instead of the average slope, is the instantaneous slope. To find the slope of the tangent line, I use the difference quotient. To find the point of the tangent line, we're going to plug that back into the original formula. So, what is the point? What is the slope? What is the equation of the line? The point is easy. To find the point, I just take the x and I plug it in here. That's going to be 2 minus 3 times 2 squared. Well, that's 2 minus 4 times 3 is 12, which is negative 10. So the point is x equals 2, y equals negative 10. What is the slope? Now, this is a little bit tougher. So for part B, the slope, because I'm at a point instead of 2 points, I have to do difference quotient. 2 minus 3 times x plus h, quantity squared, minus the original function, all divided by h. Remember, this is x squared plus 2xh plus h squared. So that's going to be 2 minus 3x squared minus 6xh minus 3h squared minus 2 plus 3x squared all over h. Let's look for things that cancel. Well, 2's will cancel. The 3x squareds will cancel. So I'm left with a negative 6xh minus 3h squared all over h. They all have h in them, so this h will cancel with that one and one of those. So now I have negative 6x minus 3h. Now I can say h equals 0 because I won't be dividing by 0 anymore. And I just get negative 6x. But remember, negative 6x is the slope at every point. I don't want the slope at every point. I want the slope at the point x equals 2. So add x equals 2. My slope is negative 6 times 2 is negative 12. So now I found a point. The point that I found, 2, negative 10. The slope I found, negative 12. Your formula is y minus the y value of the point equals m x minus the x value of the point. So it's y minus the y value of the point was negative 10. So I'm going to make that plus 10. The slope we found was negative 12. X minus the x value is 2. You can stop there if you want. You've answered the question. What's the slope, or what's the equation of the line? There's the equation of the line. It's in point slope form. Now I know most people want to clean this up. Negative 12x. That's going to make positive 24 minus another 10 is going to make positive 14. And there's the equation of your tangent line. Remember, tangent line is the point, and then the slope from the difference quotient.